Okay, so now up to this point, you have developed agents with Microsoft Agent Framework. You have also developed agents with one or multiple tools. And just now in the previous video, you understood that how we can associate agent with human in the loop kind of a scenario. Well, this is the time we have to focus on the most important part of Microsoft Agent Framework, and that is multi-agent development. Yes, my name is Maruti, and I am going to bring multi-agent orchestration patterns to you in this particular video. If you're focusing on developing enterprise level solution, then two things are must. First thing is you're going to have multi-agent solutions. It's not going to be one single agent who's going to do multiple things, but it's going to be a team of multiple agents who's going to be working with that. Second thing is when you are working with multi-agent, you have to focus on how exactly your agents are coordinating with each other, how exactly agents are going to talk to the multiple tools. And this coordination of execution is one of the most important thing to make sure that your application process and the human interventions and everything else, which is basically going to be done by your agents, should go smooth. Now, today we are going to understand 5 different orchestration patterns which are part of multi-agent development. And out of that, one of the orchestration patterns I'm going to show you practically in the lab as well. So without wasting time, let's get started. Now, as you can see right now, I have 5 different orchestration patterns which I'm going to explain. And these are basically all those patterns which are associated and supported with Microsoft Agent Framework development. We have a names of the patterns like concurrent pattern, sequential pattern, handoff pattern, group chat, and magnetic pattern. Now, obviously, all these patterns are sounds really confusing when you see and heard the name first time. But today we are going to do a deep dive into this. So instead of going with this particular slide right now, I will come back to the slide. And before that, we need to understand this step by step. So let's get started with this with one important term, which is orchestration. Now, if you have a question in your mind that what exactly this word means, then the definition says that orchestration is the coordinated automated management of multiple IT tasks. So basically, this is a word which is used in multiple scenarios. If you have worked with containerization, then in that also we have something called container orchestration. If you have worked with some IT operations like DevOps and all, in that also we have orchestration available. Now, same way, we are going to focus on orchestration for agents. This is basically going to focus on coordination of automated management of multiple IT tasks, processes, or services to achieve a larger goal similar to a conductor leading an musical orchestra. Now, if you can see here in this image that there is a person who's standing in the center. Now, if you have ever seen musical orchestra, there are multiple musicians who are going to play their own instruments. And this person who's standing in the center with the stick, he's actually known as conductor. He's going to be the one who's responsible for the full musical flow. Based on his hand movements, other musicians are going to play their instruments. Same concept is here in multi-agent workflows. When you're dealing with multiple agents, the orchestration is actually going to help you how you want to control the flow. Who's going to do which task and in which order? That's something which is very important. And don't forget, because you understood human in the loop kind of a scenario, there are chances a human has to come into a picture and sometimes human has to take control. Keeping all this thing in mind, you have to understand 5 different orchestration patterns, which are basically going to help you to execute the flow of your multi-agent development. So the next thing which we need to focus is what are the types? Well, one of the easiest and simplest orchestration is sequential orchestration pattern. Obviously, this is one of the easiest one, but that does not mean that this is not a useful one. Most of the time, initially, you have to use sequential orchestration pattern because most of the processes which you want to achieve is obviously divided into multiple subtasks. Keep this thing in mind that if you have one complex step or complex goal which you want to do, and then that goal you want to divide into multiple subtasks or steps kind of a thing, then sequential orchestration is perfect for that. This is basically going to work best when your tasks need to do some step-by-step kind of an execution. With each step is going to improve on the last one, and the order in which agents run is fixed. So remember, in sequential orchestration, you're going to provide some input. First agent is going to work on that. For example, let's say one of my agent is trying to do some summarization of the text which I'm giving. Then it's going to provide that particular logic inside that. It's going to do summarization in maybe 1 or 2 lines. And then after that, it's going to pass on that to the next one. The second one is going to also decide it beforehand that which order these agents are going to be executed. And then agents are not going to decide what happens next. So remember, the agents don't decide what happens next. You have to decide. As a developer, you will be focusing, okay, first agent is going to be summarizer, second agent is going to be translator. Maybe it's going to translate those two lines into a specific language which we provide. And then after that, the third agent is basically going to be focusing on QA. Now, this kind of sequential execution with the steps is what which is perfect for sequential orchestration scenario. And this is one of the simplest one. So I don't want to explain much on this. I hope you understand that. At the end of the executions is going to give you final result, which is obviously a consolidated output of agent 1, agent 2, and agent 3. And that's what sequential orchestration do. Now, moving forward to the second type of workflow, which is concurrent orchestration, which is little bit more advanced than sequential. In this case, what happens is, again, you are going to provide some input. And when you provide the input, multiple agents are involved in this orchestration, but they are not going to have some sequential step-by-step execution. Instead of that, they are going to work parallelly, concurrently. So this pattern is perfect when you need a different approaches or ideas to solve the same problem. Think about this. If you have one particular problem and you know that there are chances you can solve this problem by maybe 2 or 3 different ways, do you need a sequential execution in this? Of course not. You need to make sure that all 3 different ways should be executed in a parallel way so that at the end of the day, we can see that which one has completed the job in a right manner, or maybe in the faster time, or maybe it's going to be some other criteria based on which you want to check this thing. Now, instead of having agents work one after another, they all work at the same time. That's what you have to focus on in the concurrent orchestration. Obviously, this speed up the process and covers the problem from many angles, and that's one of the advantage of concurrent orchestration. But also keep one thing in mind, concurrent orchestrations are going to execute agents execution parallelly. So this is one of the scenario where you need a higher bandwidth. When you have developed agents with me, you know that there is something which is called TPM, tokens per minute kind of a limit, which we always specify in the quota when we deploy our language models like GPT-4 or some other models. Now, in this case, if you want your multiple agents are going to do a concurrent execution, obviously you need a higher bandwidth, you need a higher quota. So this is something which is going to save time, but yes, it's also going to increase a cost or a bandwidth cost, which you have to keep in mind. So there are chances when you have 3 to 5 different agents running parallelly and trying to do different things with that, it needs a higher tokens, which means it is going to be more expensive. It can complete the task in the lesser time, but cost is going to be higher. So just keep that thing in mind. Now, one obvious question which people ask me at this particular point is it possible that I can combine sequential and concurrent orchestration in my solution? 100% yes. You can do this thing. Actually, in every project, we always have certain processes which we have to make sure that we execute sequentially. And sometimes maybe we do not want to waste much time because these are dependency relevant or maybe independent tasks are there, then you can execute them concurrently as well. So yes, if you want to combine both of this, you'll be able to do that thing for sure. Third one, group chat orchestration. Now, if you understood the first and the second one, group chat orchestration is actually focusing on collaboration. So if you see right now, this is saying that group chat orchestration models collaborate conversations among multiple AI agents and optionally even a human participant as well. So in this case, your multiple agents will be there. Like you can see here, I have agent 1, 2, and 3. Let's say the agent 1 is focusing on some marketing related work. The agent 2 is focusing on engineering related work, and the agent 3 is focusing on finance related work. Each one is dedicatedly focusing on one specific task and that specific domain. With this, you also have one particular group chat manager. Now, technically, group chat manager is also going to be one additional agent who's maybe behaving like a orchestrator agent kind of a thing, or maybe you can call it a conductor with respect to musical orchestra. This group chat manager is going to be the one who's coordinating with all these things. Even there are chances that you're going to have a human who's coming into the picture, and human intervention is going to control the execution flow if required. The group chat pattern is basically, as the name suggests, that you have a centralized group chat manager is going to take care of the coordination and execution. If you observe in this particular pattern, input is taken by group chat manager. Result is given by group chat manager, and coordination of all other agents as well as human is done by group chat manager. And that's the reason I'm saying this group chat manager is a centralized conductor or an orchestrator who's basically going to take control of the full execution. So this pattern works very well in the scenarios where group discussions or iterative collaboration is a key to reaching decision. So we do not know which one is going to be the final one, how many turns is going to be coming. It supports different interaction styles as well. So from free-flowing iteration to formal workflow with defined roles and approval steps can be customized inside this. The group chat orchestration is also great for human in the loop kind of scenarios where a human may guide or intervene the conversation as and when required. Typically, agents in this pattern don't directly change running systems. They mainly contribute to the conversation, and based on that conversation, group chat manager is the one which is going to execute things, which is going to provide the result, and maybe if required, the group chat manager is going to take a support of the human as well in this. And that's what group chat orchestration is focusing on. Now, as you can see here, it can be having multiple ideations or formal workflow executions with that. So there are n number of possibilities which are available in group chat orchestration. Most of the time, this kind of orchestration patterns are going to use multi-agent with multiple tasks. So basically, in this case, it's not like one single task, but it's going to have a sequence of multiple tasks, and we do not know which one is going to be working in which order. And that's why the group chat is basically going to create some kind of a collaborative conversation, and based on that, we are going to get to some particular result or a final output. That's what it is all about. Now, if you understood these three, sequential, orchestration with concurrent or parallel, and the third one, which is group chat orchestration, it's the time to move forward to fourth one, which is handoff orchestration. Now, this is one of that orchestration where people get confused with group chat actually. So I do not want you to get confused, and that's why have a look at this first. In this case also we have multi-agent. One of my agent is taking input, other agents are working on that, and then somewhere the result can be given by any of these agents actually. So you can see that in this case multiple agents can actually give you result. That's a big difference compared to group chat manager. Also, there is no one centralized coordinator kind of a system. In this case, agents are going to work turn by turn. They're going to pass on the work to the other agent, and maybe the other agent is going to pass on the work to further agent, or maybe sometimes agents are not able to complete the work, so they can pass on the work to the human as well. Now, handoff orchestration is going to let your AI agent transfer the control to one another based on the task, context, or the user request. Basically, the word handoff is actually explaining a lot many things, because it's saying that your agents can hand off the conversation to another agent with the right expertise. So whenever your agent thinks like, oh, this is not my expertise, maybe another agent can do this thing in a much better way than me, then it's going to pass on that to the next agent, and that's what handoff is all about. Now, this pattern is ideal for customer support. Think about the scenario. Your customer is requesting for some kind of a support with the initial input in the natural language prompt. Based on that, you're one of the agent, let's say you have agent A, which is general support agent, is going to take that particular input. Based on that, maybe general support agent can provide the response, then it's going to provide the result, and that can be done with one single agent itself. But there are chances that this is some technical support related issue, which general support agent cannot be able to fulfill. Then it's going to pass on that to the technical issues to agent B, which is basically a technical expert agent. Agent B is going to do the needful things, and then it can give the result. The third possibility is this, that agent A, which has taken the general support, is identifying that this is not a technical issue, it's a billing issue. Then it's going to transfer this thing to the agent C, which is basically dedicatedly handling the billing issues only. And then agent C can give the result to the user. Or there are chances that it's not a general support, it's not a technical expert kind of a support which is required, it's not a billing issue also. Then for all other issues, maybe this general support agent or any other agent will not be able to fulfill the user's request. In that case, maybe it's going to give some kind of a phone number that you have to coordinate to this human being. You have to call that person, explain your issue, and then maybe you'll get the support. This is what happens mostly in the customer support systems. And that's where human is also coming into picture, and then maybe human is going to take care of the result specific things. Now, you can use expert systems or any other situations where dynamic delegation is needed. Remember this word, handoff orchestration is equals to dynamic delegation, because this is going to give control to other agents or even human, and based on that it's going to fulfill the required result which is required for the user. So that's how it's going to be working. Now, as I said, chat manager and handoff orchestration. Now, both of these are basically having multi-agent kind of a configuration, but the differences are this, that handoff orchestration is basically going to have some kind of initial path which is decided. For example, input is always going to be taken care by agent A, which is taking care of general support. And if that is not possible, then it will go to the other agents or maybe to the human. One of the issue of handoff orchestration is also this, that it can maybe stuck with the infinite loop kind of a scenario. Because there are chances, if none of the agents are able to complete this, or even if human is also not able to solve that thing, it will go into the infinite loop kind of an association. Now, in this kind of cases, mostly human is going to taking control of this thing and is going to either complete and give the result, or maybe it's going to give some temporary solution or escalation of the issue. Now, in this kind of scenario, there are chances that this drawback or this issue of the handoff orchestration can come into the picture, which is infinite execution. Because of this, sometimes even your end user get frustrated, which is also possible. And you know this feeling, how it feels when multiple agents are actually trying to solve your problem. You're just waiting there in the queue, or maybe you're just waiting for the response and they're just diverting from one agent to another agent. In real life also this is frustrating. In agentic development also this is frustrating. So just make sure you're going to handle the flow properly. Next, last and the most complex one is magnetic orchestration. Now, magnetic orchestration in a technical way is an extension of a group chat orchestration only. But in this case, they are doing some additional features or additional implementations here. The magnetic orchestration, instead of group chat manager, they have something which is called magnetic manager, which maintains a shared context. It also tracks the progress of the full executional work, and it also adapts the workflow in real time based on the user's input and changes. This approach allows the system to break down the complex problem, assign subtasks, and iteratively refine solutions. Now, this process focuses as much as on building the documenting the approach as is does the delivering the final solution. A dynamic task ledger is built and refined as the workflow progresses, and it's also going to record the goals, sub-goals, and execution plans. Magnetic orchestration is one of the complex orchestration to implement, but this is going to give you a best user experience to your end users. Once you implement this thing, because it is keeping track of the task ledger, because it is keeping track of the progress ledger, and then it's also giving you step-by-step task execution updates with that. Also, at the end of the task is going to give you that what exact steps has followed, what changes have done, and whether it is working and achieving the goal or not. Magnetic orchestration has one of the best real-time example, which is GitHub Copilot. If you are a developer who's using vibe coding kind of a features with your GitHub Copilot, then you know this thing that whenever you provide any complex task to your GitHub Copilot, it's going to make sure that it understands all the subtasks which are associated with that complex goal. And then it's going to give you a step-by-step execution of that. At the end of that is also going to give you executional workflow, or maybe the final outcome workflow which is associated with that. So it's actually maintaining the full executional path inside that, which is very important to keep and to understand with that. Now, this is something which is a fifth and the final orchestration workflow. Now, this is one of the complex one. So maybe if you're an experienced person, then maybe you're going to try this thing. I have some of the samples with this, which I'll share it with you. If you want the examples and repositories of all these 5 orchestration patterns, you can comment down that in this particular video, and I'll share all those things with you. But as of now, let's get to understand this 5 orchestration patterns in the quick way. This slide is showing you which pattern, what kind of a typical use case you can use this, and then how it is connected and different than each other. First, as we started with sequential, it is something for step-by-step workflow pipelines. Multi-stage processing will happen. You can pass the result from one agent to the next one in the defined order, which is going to be defined by us. In the concurrent one, is going to broadcast a task to all agents, multiple. It's going to collect the result independently because it's a parallel execution which is happening with that. Typical use cases are parallel analysis, independent subtasks, assemble decisions making, and likewise. Handoff and group chat, both are available here. Handoff is going to dynamically pass controls between agents based on the context or rules, and is going to have a dynamic workflow execution, escalation, fallback, and expert handoff scenarios are going to be there with that, with the human also associated with that. And in the group chat, all the agents are going to participate in the group conversation coordinated by a group manager. That group manager is going to be take care of the result as well as input both. It is perfect for brainstorming, collaborative problem solving, or consciousness building with that. The extension of group chat is like magnetic one. So basically the magnetic orchestration which is there. This is going to be useful for more complex, more general multi-agent kind of a collaborations, which is basically going to maintain the task ledger. It's going to update with that ledger. It's going to have a memory. It's going to have an executional flow. Also keep in mind. So it's basically the advanced version of group chat, which is there. Now remember one thing, most of the time when you're developing multi-agent, my golden advice to you is start with the basic orchestration patterns for multi-agent like sequential and concurrent. Okay, you have to start with these two. Do not try to make things very complex unnecessarily, because there are chances in almost 60% of the projects sequential and concurrent executions will solve the problem. Suppose if you feel like now this is not done by sequential and concurrent, and if you really need handoff, group chat, or magnetic one, then you should go with this. Remember, when developing multi-agent solutions, cost, security, and control and efficiency on that output is a very important thing. When you go with more complex orchestration patterns, and if you're not able to manage it properly, maybe you'll end up with higher cost, maybe you'll end up with some infinite loop execution kind of thing without giving a proper accuracy in the result, and maybe there are chances you'll end up with frustrated user or some kind of a drawbacks with that. So make sure you try this thing first, and if this is not able to satisfy that, then you can go with the other three complex orchestration patterns. And that's what my advice is. And that's one of the reasons we are going to deal with the first sequential orchestration pattern with multi-agent right now. I have one sample which I have published into the same repository, which I'm going to show it to you right now. So let's get started with the lab example right now, so you can understand how the code with this one is going to work. Okay, now if you check my Visual Studio Code right now, I have pushed a new sample into the same repository, which is available on this particular URL. So I hope you have followed the series and you have done the first 4 samples which we have created with the agentic framework, which is Microsoft Agent Framework basically. So you can go to the same URL of this particular Git repository. You'll get this 05 folder, which is focusing on multi-agent sequential workflow. And in this case, I have already set up my project. So I'm not wasting time in, again, creating a new project in the Microsoft Foundry portal. I have already set up that. I have GPT-4o available. So my project endpoint and my GPT-4o, which is my model deployment name, I have already mentioned in my environment file. Requirement.txt is same. You need agent framework. You need Azure identity for authentication. So that's also not a big deal. We have done this thing in all other samples. If you have not seen my other samples and other videos of this particular series, I request you to please check out those videos. That's really going to be important that you do this thing in the proper manner, then only you'll understand everything. I'm not repeating the same steps again. Moving forward to the code. If you focus on sequential agent workflow file, this is basically focusing on multi-agent sequential workflow. And in order to make it working, you have to execute these 3 commands in your terminal. So basically, you have to right-click on requirement.txt file, open an integrated terminal, and you have to enable a virtual lab environment first, in which you can install the dependencies. I have already done that thing. You can see inside this folder, the lab environment folder is already there. So my virtual lab environment and the dependencies are already installed. Still, just to make sure it is already done, I'm just going to execute this pip install command with my requirement.txt so that I can understand whether this is actually done or not. Yeah, I think you can see it's already showing me already satisfied, already exists, and it's done within a second, which means I don't need to do anything. Now, let's focus on the code. Initially, we are again adding a references, where the most important reference is reference which are coming from Microsoft Agent Framework. And in this, we have a new thing, which is sequential builder. This is that class which is helping you to build your sequential workflow orchestration. We also have one thing which is workflow output event, which is basically going to capture the output events and is going to give you the final results with that. These are the two new classes which we are adding in this particular code, and we'll use this thing in our code. Because I want to deal with multi-agent orchestration, I have created three variables right now. Just have a look at this. I have my three different variables which I've created right now. The first variable is the instruction for my first agent, which is summarizer. Second one is classifier, and third one is action. So basically I have three different agents. Each one is going to do one specific task. So my summarizer instruction is basically focusing on the first step, in which my user is actually going to provide some input feedback. Now assume this particular application is going to take a user's feedback, and based on that is going to analyze that this particular feedback is a what type of feedback. So it's going to do summarization of the multi-line feedback into one-liner. It's going to also classify that whether this particular feedback is positive, negative, or it's something which is a feature request done by the user. And it's also going to suggest me some actions which I need to take based on the user's feedback. So this is basically what is happening in the three different steps. And I hope you agree with me. This is something which is going to be something which has to be done in a sequential manner. So initially, when user is going to provide some feedback, my summarizer agent is going to take the customer's feedback in one short sentence. So it's basically going to summarize that in one short sentence. It's going to keep it neutral and concise. And I'm also giving you some examples here. So basically, I'm using a technique which is known as few shot learning. I'm providing some examples here. And I'm going to say you're going to provide a summarizer with one liner like this: app crash during photo upload. User praises the dark mode feature, something like that. And it's going to understand this example. It's going to give me the result based on that. Then you have a classifier instructions in which it's going to classify the feedback as one of the following, like positive, negative, or a feature request. Simple. And then we have a third agent which is going to do based on the summary and classification, step number 1 and 2, is going to suggest the next action in one sentence. For example, it's going to say escalate a high priority bug for the mobile team. So which team and what task? Log as a positive feedback to share with the design and marketing team, or log as enhancement request for the product backlog. It's going to give you this kind of a one-liner action instruction at the end of this. Now, to understand this in my code, I have implemented this three agents with these three instructions. So basically right now these are just three variables. We are going to use them in the agentic development. And in order to do that, this time my number of lines of code are really reduced. All the extra thing which we have done in the previous lab samples, I have not done this here. If you see, the credential instance is created with Azure CLI credential, just a one-liner. After that, I have created Azure AI Agent client, in which I'm passing my credential, and then I'm just creating a chat client instance. And once you do this 2 lines of code, your initial configuration is done. Yes, that's how it is. Cool. And chat client, which is basically my instance of my Azure AI Agent client, is the one which is allowing me to create my agents. Now just observe one thing. This creation of the agent is very different than the previous agent which we have created. This time it's having a syntactic sugar basically, and I'm just passing my instructions which are coming from those three variables which I have declared on the top, and I'm not passing any kind of a model. So I'm not passing GPT model like 4.0 or something like that. That is already mentioned in the environment file. In my full code, I'm not mentioning, is directly going to take it from the environment file only. The name of the agents I'm giving summarizer, classifier, and action, and that's it. These 3 lines are going to create 3 agents. After this, I'm providing one variable which is basically a feedback. This is going to be used as an input from the user. So I'm providing one 3-liner feedback, which is saying I reached out to your customer support yesterday because I couldn't access my account. Okay. The representative responded almost immediately, was polite and professional, and fixed the issue within a minute. Honestly, it was one of the best support experience I have ever had. Now, this is one particular feedback which user has given, and I want to see that my 3 agents are capable enough to process this or not. So after this, I'm adding an important line here, which is basically workflow, which is my variable, and I'm calling that class which is sequential builder. This is that class which is going to define your executional flow of your multi-agent. And you can see this is as simple like this. You're going to pass on multi-participants of this workflow. I'm specifying summarizer first, then classifier, and then action, and this is going to follow the same order. And at the end of this, you're just building this workflow. It is as simple like this. You're just putting up blocks in your tower. So basically, it's like first block, second block, third block. You added this thing and done. After this, in order to get the executional output of this, we have run stream, which is basically going to give me a workflow specific execution. This particular function is very similar to your run method for the single agent, but this is going to take the full output of the full executional stream for that particular workflow, which can have multiple events. And that's the reason we are running a for loop. For each event in that workflow is going to fetch the output using workflow output event class, and it's going to print that particular event data so that I can see what exactly response I'm getting from each agent in that sequential manner. In order to display the output, we are running one more final loop, which is going to take that outputs, and based on that, up to the end of that particular message, is going to print whatever output we have received from the different agents. This is as simple like this. In less than 100 lines of code, we are actually done. It's not even 100 lines because of the instructions and all. We have added more lines. It's just a 20 lines of code which we have done here. And your 3 different agents with sequential workflow execution is actually done. If I want to run the sample, I am going to my terminal. I'm going to execute Python, and I'm going to specify my file name, which is sequentialagents.workflow.py. Remember one thing, if you are running the sample first time, you have to execute AZ login. Don't forget that. You have to authenticate with Azure Identity first. I've already done that thing, so I don't need to redo this every single time. And that's the reason I requested to go with the first video first and then understand this with the loop. So this is what I'm doing. I'm running the sample application. Let's see if this is associating with my project, creating multiple agents and executing them or not. Yes, my agent execution is done. As you can see here in the output, it's showing me that first I have a customer feedback, which is printed here. This is the same feedback which we have provided. And then it's showing me second one is summarizer. So user has provided this input. Based on that, my summarizer agent is giving me one line summary that positive experience with prompt and professional customer support resolving account access. So this is perfect. Classifier is saying this is a positive feedback, so that is also fine. An action taker is saying that log as positive feedback to share with the customer support and HR teams, which is basically saying that this is a perfect one. Now let me change the feedback a little bit. So I'm saying that I reached out to customer support yesterday because I couldn't access my account. This was all thing which was an older feedback. Let me change the feedback. I'm going to say that I really liked your app and it works very fast on my phone. However, I encountered a problem when trying to upload photos. The app crashed every time I attempt to do so. It would be great if you could fix this issue in the next update. Also, I love the new dark feature. Now, this is the full feedback which I've given here. And let me check for this particular feedback what kind of an input this is going to take. So I'm going to save this file. I'm going to run this project once again. Last time it was positive. This is something which was saying that it's going to go to HR teams and all. Let's see this time what they are saying with this in the one-liner summary, classifier, and action. It's done. Have a look at this. This is my new feedback. Summarizer is saying app crashing during photo upload, but the user appreciate the dark mode feature. Classifier is saying this is negative, even though it's saying dark mode feature is good, but this is crashing, so basically it's negative. And they are saying escalate as a high priority bug for the mobile team and log the positive feedback for the design and marketing. It's basically combining both and giving me one liner that this is a good thing, this is a bad thing, this is how we have to handle that. My agents are working fine. My agents are working in the specific order sequentially, and that's what I wanted. I hope you understood the sample and I hope you like this particular video. If yes, I request you to please click on the like button of this video and subscribe to this channel. This is free for you, but it's really going to help us in growing. That's it from my side. I'll see you tomorrow in the next video.